Hello everyone and welcome to a new discussion on groundwater exploration. This is part 6 and whatever we have discussed in earlier discussions from between 1 to 5, we are going to continue on the same discussion, but this is part 6. So, let us start. As you many of these things earlier I have touched about in groundwater exploration, the first or one more step which is required, geological and hydrological methods. So, we discussed a lot about how remote sensing and GIS can play important role in case of groundwater exploration, especially at the preliminary stage or sometimes even in planning stages also. Similarly, geological and hydrological methods are equally important in groundwater explorations. As we know that based on whatever the preliminary conclusions which we get concerning many aspects of groundwater occurrence and yield prospects can be drawn from geomorphology and geology of the area, and whatever the structural features which are present there also in the rocks and overall in the area, or structural features of the formations, individual formations as well. So, these few things, geomorphology important one, and of course, geology, and the purpose of all these exploration techniques or discussion on exploration is to search for groundwater occurrence and what are the yield prospects, how much water we will be getting, how long the water we will be getting. You know, the types of details in such geological and hydrological methods of groundwater exploration required, about which we put them as geological prospecting, and which differ from the one rock to another, because the geology for each area is unique, and this has also been discussed earlier. Topography is also unique, and therefore geomorphology and hydrology of each area is unique. But learning and developing knowledge about certain geologic formation structures and geomorphology, we can still create different zones on which our work will become little easier about the groundwater exploration. So, further in geological investigations or geological methods, knowledge of stratigraphy, those who do not have background of geology or earth sciences, let me very briefly explain here about the stratigraphy. This is the arrangement of rocks and especially related with the age of rocks. So, knowledge of stratigraphy and structural geology, that is means the structural features present in the rocks, especially which influences our groundwater movements, that is what is that information or that knowledge is very useful to overall understand the geological setup, which because geological setup will also influence our hydrological regime and other factors also. So, this is the basically understanding the order of superposition of various lithological units and their continuity, and in stratigraphy the superposition we also add the age. Generally we expect that the older age rocks will be at the bottom and younger ages rocks would be on the top, but due to some structural or tectonic activities this sequence may be even reverse also, and in some special geological conditions like in fold, anti-formal or synformal, again this stratigraphy might be different. So, we have to understand, because this helps us to understand overall hydrological regime of the area, and which is of course related with groundwater exploration. Further, the petrographic description, that how the rocks are there and whether they are igneous, sedimentary, metamorphic, and even within sedimentary how the mineral content are varying, their constitution is varying, that kind of information is also useful, which will give the indications regarding consolidation, how rocks are hard or soft, how they have been consolidated or compact. Second, they will give information about the cementation, how these, if I give the example of sedimentary rocks, then how these silica grains or sand, if I say medium to coarse grain sedimentary rock, then how these grains have been cemented by a natural cementing material, That is also important, because all these will influence our porosity and permeability, and of course porosity of rocks and their water bearing and yield characteristics. So, this petrographic analysis can help us to further understand the geological setup which might be existing in an area. So, for that what we do, we initially we go first for topographic maps and satellite images. Then later on we also go for geological maps, which will describe or which will give you the overall idea about the arrangement of rocks in an area. And all these information which I have just mentioned would be helpful to form the basis of deciding the exploration techniques, which exploration we should go, surface exploration, subsurface, even for test drilling. So, all this will be based on the geological, topographic, geomorphological, and whatever the information we can gather or extract from remote sensing data analysis, all will become our basis for further decide about the exploration techniques. And for individual areas, again the exploration techniques might be different. So, most suited to the area and type of drilling rig to be deployed, depending if we go for test drilling, what kind of drilling rig will be deployed, because there are different techniques of drilling. So, in this course we will be also discussing whatever the known drilling techniques which are directly related with the groundwater engineering. Not drilling techniques we will be discussing which are related with petroleum and other purposes. So, mainly we will be in drilling techniques, different drilling techniques, we will be discussing mainly on the related with groundwater engineering. So, after this geological maps of the target area, if in some cases may not be available, then we can do whatever the interpretations are possible through remote sensing data, and should exploit remote sensing data to maximum, so that whatever the geological information we wanted in the absence of geological maps can be obtained as far as possible, and then interpretation of groundwater. So, all this remote sensing data, whenever the analysis and interpretation is done, the focus should be that we are doing this analysis and interpretation of remote sensing data for groundwater. That should be all the time focus in this field, if geological maps are not there. Even if geological maps are there, we should exploit remote sensing data to the maximum, because this is much easier to do all kinds. Second is many times the geological maps might be available at a very small scale. No, that means not much detailed geological maps might be available for a small area. So, how to get a good geologic information, then in that case we can still employ remote sensing data or relatively higher spatial resolution to get this information directly or indirectly about groundwater conditions. Secondly, remote sensing data can also be utilized to study fracture patterns. Remember that when we have been discussing hard rock terrain and unconfined aquifer conditions. So, two things which favors groundwater movement or groundwater storage or groundwater recharge is the fracture or lineaments or faults, and the second is the weathered zone. So, these two things are very important. Similarly, in case of any other rock types, may not be all the time igneous rocks or granitoid or granite, gneissic, maybe sedimentary rocks, maybe metamorphic rocks, but this fracture pattern is very important to study, and this can be easily studied you implying the remote sensing data, which because this fracture pattern, why they are important, I will repeat that they govern the accumulation and flow of groundwater in hard rocks. So, they not only this, but let me also add, they also control about groundwater recharge. And in previous discussions I have shown that how along the fracture or lineaments good growth of vegetation can be seen. So, that means they made the water available which plants can exploit and can grow on that. So, these are very important. Fracture patterns in hard rock, we are not talking about fracture pattern in alluvial plains, which you will not get anyway. So, it is all the time in hard rocks, and in groundwater studies hydrological aspects should be combined with the geology of the target area. That means the hydrology should not be looked or analyzed, thought in isolation. Geology and hydrology should go together, so that we get a much better understanding about an area before any further steps like geophysical prospecting or geophysical exploration or for test drilling is done. So, all these whatever the data is available in different forms, that should be first analyzed, integrated geological and hydrological investigations. So, a combined approach of these two geological and hydrological applications or techniques would yield better results. When we go for test drilling or geophysical prospecting or exploration, we will get better results, because we have developed the understanding of surface of the ground or earth surface through this analysis, geological and integrated analysis of geology and hydrology. And then information about meteorology. Rainfall plays very important role, as we have also seen that places because all conditions might be favorable from groundwater point of view on surface, but if we know through meteorology or this data that hardly there is a rainfall, then we do not have much chance of getting water. So, these are unless we are having a completely confined aquifer conditions, and these confined aquifers are getting recharged from elsewhere, then that is a rare case. So, information about the rainfall, especially precipitation, is very important, and other aspects related with meteorology, temperature and humidity also plays a good role or important role in case of hydrology. Next information which is required about the soils, the pedology and the science of soils, that is pedology. So, that is also required. The chemistry of water and other disciplines, so chemistry of rocks or chemistry of soils is also important, which might indicate some important aspects related with geology or hydrology overall. And generally the older formations are less water bearing and less productive. Because we have discussed the stratigraphy, so in stratigraphic knowledge, if we are having of that area or available through some publications or some organization like Geological Survey of India, then we would know that the formations, rocks which are older, there are less chances of getting water and less productive. Younger rocks will have, because they are generally less compact. However, after saying this, sometimes older rocks, even if they are exposed on the surface, they will have fractures and they will have weathered zone also. So, in that way they can have water bearing unconfined aquifer conditions and may be productive to some extent for some months, and may not, because they are not confined, but nonetheless this thing should also be kept in mind while doing this geological and hydrological exploration. Now, this structural features and other things which I will be giving you more details about, that is how they influence our groundwater conditions. That normally what we see that like older formations, here younger formations overlie the older ones, but not necessarily. If there is some tectonic activity has happened or some structural features are there or faults are there, this sequence may be not normal. That means the younger formations might be at the bottom in the sequence and older formations might be on the top because of tectonic activities and other, or thrusting and other. But in case, if suppose this is the normal sequence is that younger formations overlie the older ones and are reached earlier during drilling, but expectations may be exceptions may be found in this. So, like here, if we are having some geological structures like sills, dikes, or these ultra basic dikes or other intrusions, then the entire setup may change, because these may be impervious layers. They may not allow water to flow in any direction through it. So, neither from top, but however they can serve as a impervious layers and the bottom part may become if there is good recharge and other things, bottom part can of this sills can become our can be useful from confined aquifer points of view. These quartz reefs we have discussed in earlier discussions, but very briefly these are the on the surface. Here in the left figure you are seeing in a section along the road section, but here from through satellites in this one you are seeing from the top. So, quartz reefs which are also some kind of dikes which serves as a barrier from groundwater flow point of view, but they are not completely solid. There are a lot of fractures in it, and weathered zones are also there, and might be some gaps between these things. So, therefore, the water may flow through them, but the knowledge, geological knowledge of these all these features are important before we decide anything, or before we do some adopt some techniques which requires a lot of resources. So, whatever the information which can be easily gathered should be gathered first, then expensive options should be explored. So, this is what is is the where the intrusions has occurred into older formations. These are the older formation where intrusions have occurred. Similarly, in the granitoid or this Bundelkhand gneissic complex you are seeing. Now, another closely folded formations resulting in overturning of strata. Here as you can see that depending on inside if I say antiform, inside there might be older rocks, or here maybe the younger rocks in the outside, and a reverse situation can also be there in that younger rocks inside the core, older rocks might be outside. So, that has to be checked, because normally we have said that the older rocks are having poor support for the groundwater movement and storage as compared to younger rocks. And similarly, if we are having some faults or overthrust, like here in a section the fault is shown, and so the water suppose there is a recharge, this will happen here, but because of this impervious layer nothing will go further. So, that this layer cannot become a confined aquifer condition, but if through faults or other things, if water is allowed to go, then these layers can become confined aquifer conditions. Like though this is example from hard rock terrain or sedimentary sequence, but in case of like Indo-Gangetic plain which occupy a very large area of India, you may have a situation something like this in subsurface: sand layers, then clay layers, then sand layers and clay layers, and therefore, it is possible in Indo-Gangetic plain to have confined aquifer conditions or purged aquifer conditions. Most of the time you may get unconfined aquifer conditions at the top, but if the bore well has been or this bore well has gone deeper, one may encounter a confined aquifer conditions. But structural information, faults and overthrust plays very important role in case of groundwater movement and occurrence. However, in general the crystalline rocks, means when we say crystalline rocks, generally we are talking about hard rocks from groundwater point of view, are regarded as the basement, means they are at the bottom, older rocks are at the bottom, this is what we say, or crystalline rocks at the bottom, and there is no purpose which does not serve a purpose in penetrating them if permeable layers have been penetrated above it. So, sometimes you may get, if you recall an example where I was showing that in the basement we are having Bundelkhand granite and top of which you are having Deccan traps. So, Deccan traps are much younger than Bundelkhand granites, and water going downward in a granitic body is very difficult. So, water may remain at the top layer, younger layer, and might be permeable as well. Weathering we have been discussing, and this figure also came earlier in our discussion, and that wherever we are seeing like granite boulders in there or some temporary streams are there, then we expect that this weathered mantle, the top part of in a hard rock terrain like in granitic terrain between 0 to 3 or 0 to 5 meter is weathered, which will support the groundwater recharge and then you encounter water surface, which you can see piezometric level or water table here, and in the basement, this is fresh basement when we say, or crystalline basement means hard rock which does not allow much water to go, but if there are fractures which are going through, till then you are having a zone or a thickness of the unconfined aquifer. So, weathered zone in hard rock terrain, if they are exposed on the surface, is highly possible, and chances of getting a unconfined aquifer condition is also possible. But the storage is, how long or how much yield would be there, how long it will provide the water is a little difficult in this situation, because you do not have much storage space available in these hard rock terrains. If weathered zone is quite thick and this fractured granite and that part is good, then we may have quite thick unconfined aquifer. Otherwise, for few months the water might be available and remaining months no water is available. Now, further in hard rock, especially crystalline rocks, topography and stage of geomorphic evolution. Topography, undulations are there, and how these arrangements at the top means geomorphology of the area, how it has evolved, can give also lot of information about the development of weathered rocks, how weathering has taken place. As we can see that in these granite terrain in many parts of India, you would see that there are a lot of boulders on the surface, and they are telling that these have been existing since long time, and because of weathering and erosion, and this kind of boulders are on the surface. So, they indirectly tells about the geomorphic evolution of the area, and from that sense. But we are more focusing on weathering, how much weathering, how deep weathering, how extensive weathering in vertical direction as well as in horizontal direction. Further, also the mineralogical composition and textural characteristics of the rock determine the degree to which it can weathered. Like if I give this example, this is a Bundelkhand granite, or overall if we say Bundelkhand granitoid, nice granite or gneissic rocks are here, and quartz reefs is here. Because of mineral composition of granite, which is quartz, feldspars and mica, in this area I am talking, and then relatively mica and feldspar are less stronger or more weatherable than quartz. So, these quartz reefs which you are seeing here are purely quartz, made from quartz mineral, whereas the surrounding rocks are granite, and in which mica and feldspar got weathered, and therefore, these quartz grains could not remain, and they too has got eroded from all this area, whereas quartz reefs remain outstanding. What I am trying to say, that when these quartz reefs were formed, it is not necessary that at that time quartz reefs came at outstanding above the ground, maybe at the same level of the ground, but the remaining ground except quartz reefs have got eroded, weathered and eroded, and therefore, we see today the quartz reefs are outstanding. So, that means that mineralogical composition of rocks plays very important role, along with textural characteristics of the rock, how what kind of size of grains are there of different minerals, what kind of textural arrangements in the rocks are there, because that weathering depends on all these aspects, and will depend on the degree at which it can be weathered. And generally what happens, if there are large grains or small grains together in a rock, then there are more chances of weathering, and if mineral composition is also like that, like feldspar you are having, mica you are having, quartz you are having, then again this combination of these three minerals, two are relatively weatherable than one, then overall granite will also get weathered. So, type of weathering will influence which are the processes going on, and then how these rocks will react, and nature of resultant product. What is the nature of resultant product would be there. Generally in this case Resultant product is of course you get the sand which is more or less silica, quartz grains, and your feldspar and mica has completely weathered. Now we continue on this weathering, and you may get as I was saying boulders and other things, but there are some other geomorphic features. In cell work can also be seen. This is from southern India near Bangalore, Karnataka. You can see this is again a completely granitic terrain, a batholithic area, and you get weathering. Some parts of those rocks have got weathered, but remaining hard part of that or quartz rich rocks are less liable to chemical weathering, feldspathic rocks also. And because the what I would say the composition or mineralogy of a rock exposure or rock in an area is not constant, it varies place to place. So, if in an area, suppose in this area, if I talk about this area, and suppose there were more feldspathic rocks or rocks which were rich in feldspar rather than quartz, and then they got weathered much easier than this part. So, it depends on the mineral composition of within even the same rock, these can vary. And erosional residuals, these are the Inselbergs are erosional one of the erosional residuals like Inselberg, Tors etc., which forms the upland comprising massive and commonly spiraling fracture rocks. These are highly fractured rocks. You can also see some vertical fractures and other fractures can be seen here very clearly. These are again the study of these fractures are important, which will give you about idea about the occurrence and yield of groundwater, and also they will indicate about the information or about the recharge conditions. This is very famous in silver, so I thought I will bring here also, which is it is called Uluru and or air rocks in Australia. Very famous, world famous in Selberg is there. See in the surroundings, it is a completely flat, but all of a sudden you find a big rock body is outstanding relative to the ground. So, this is a side view here. This is on the right side you are seeing the top view. You can see that these are these bedding plains kind of situation which you are seeing here very clearly, they are coming. So, this information is again very important from groundwater point of view. Residual rocks which are also one Inselberg is one of the residual rock, another residual rocks are for Tor, and sometimes I was mentioning on the granitic terrain you may find boulders like this one, they are left like this, rest of the material, rest of the rocks or minerals have got weathered, the mainly hard part remain there. So, this is Kisumu, Kenya, and this is there, and this is of course balance rock of very famous balance rock of Jabalpur is there, and that remaining rock has got weathered except this special part because it is less or more resistance to weathering. Now, the after weathering, the another important thing about the attitude of beds, how beds are oriented. Here in this Inselberg, see that beds are vertically and they are almost vertical here, that is why individual bedding planes you can see from the top in this B image or right image. So, this attitude of beds, and that means that can be understood much better way by measuring their dip and strike, and that is the orientation of rocks with reference to the north. So, here this attitude of beds, like here there are the sedimentary sequences are shown here in this section or in the other view also, and you see that the rocks are dipping if this is the north, then rocks are dipping towards the west side, and very gentle dipping is there, and the dip amount is given in this schematic is 30 degree, and the direction of dip is about towards west, and a strike is this is line of a strike which is just perpendicular to your dip direction, and that is north south in this schematic. And now here you are also seeing the water is filled in this part, so that also giving some idea about that because the water when it is filled, it will take a horizontal level rather than a dipping direction. So, that is why it becomes much easier to measure. But even then if it is water is not filled, this measurement of dip amount and dip direction or strike direction can be done very easily. Therefore, attitude of rocks is very important in case of sedimentary or metamorphic rocks, which directly influences our groundwater hydrology. So, the groundwater engineers must know in any area they are encountering such rocks that what is the attitude, where they are dipping, what is the direction and what is the orientation, and this will definitely help, because if I make a borehole here, immediately I will get this rock at the top. But if there would have been some alluvial deposits here then I will encounter this rock after certain depth. If you know the attitude of beds or orientation of rocks, then this information will definitely help, and in initial stages will help to predict. So, we must know about the extent, vertical and lateral extent of these rocks, which will give us better understanding about the aquifers, associated layers which are the layers, and will help in forecasting of their depth at any location. So, this kind of information, that is the typical structural information, is very much required, especially in sedimentary and metamorphic terrain. Strata of sedimentary formations are rarely horizontal. This is very important information, is that because of tectonic activities and folding and other things, you may not get this horizontal. In Inselberg of Uluru of Australia, you are seeing the rocks are vertical. Here they are, in this example, rocks are dipping towards the west. So, it is not necessary, it is rare rather, that you would get sedimentary sequences or sedimentary rocks which are completely horizontal. They may have any kind of orientations. Gentle dips are developed due to deposition on a sloping surface, or might be because of the deformation later on which takes place because of tectonic activities. But steep dips are developed almost invariably due to deformations. See, from groundwater engineering point of view, we are not focusing more towards how these have been created or generated, how they are there currently, how they will influence my groundwater conditions, that is more important. So, we are not looking the genesis of rocks, but what we are trying to understand the characteristics of the rocks which are present today and how they are influencing my water occurrences and yield. Determining the distribution and extent of homoclinal strata, that means having uniform dips. This example is almost homoclinal, that all these rocks, different sedimentary layers or rocks are dipping almost in same manner. So, that if that is the situation, again is a rare situation, but if we get homoclinal strata, again very helpful. Because these will control our trend of aquifer in such formations, and which will make our prediction of the water bearing rocks and for drilling or for geophysical survey much easier. In the last I am going to show you two important field photographs which were very recently taken by myself, which is along Mohand Dehradun section, road section, because of road widening and some other new road construction between Dehradun to Delhi expressway. Because of that cutting, they have exposed new rocks or new formations, and I thought that these are very relevant from our groundwater point of view. See, here all these sedimentary sequence is important to note, but if you see on the top part, you are seeing one colored rocks which are generally fine in sediments, clay mainly, characteristics are clay. Then second clay layer or fine grained rocks you are seeing here. I am calling rocks, but they are not yet very compact. Basically, these are our shivalik rocks are there. We say rocks, but they are not as compact as like in other parts of Himalaya. But anyway, we will call them as rocks. And then one more thick layer of this fine sediments is there. Of course, there are some other very thin layers are also there. So, if we focus say in this section, then you see that from the orientation of strata or orientation of these sedimentary sequence plays very important role. If water is if some groundwater recharge structure is formed here, then the what would happen later on, whatever the water which will percolate after infiltration will flow like this, because this layer which is darker brown colored layer will serve as an impervious layer. There might be a accumulation of water in subsurface conditions, something like this. So, if I make a drill here, I will get water here at less depth as compared to this, and here I may not have water because the top part will become a completely unconfined aquifer conditions. Whereas by some means, if this between two impervious layers, if I get water in this, then this becomes my completely confined aquifer condition. Many times we have been seeing schematic, but this is a real section, rock section of Shivaliks, where we can understand in a much better way that how these different layers of fine sediments and coarse sediments plays very important role. The middle part here, if I give this example between two fine layered sediments, this is very coarse sediments and more or less very poorly sorted sediments. Nonetheless, these are highly porous and permeable. So, they can become a very good aquifers if at all that is the same kind of sequence is followed in subsurface. It seems that it is there. Just for curiosity, why one may think that why these layers are there, basically they might be giving you information about the seasonal variations in the sediments which are coming in different rivers. And so, sometimes you are having coarse material, say in rainy seasons, monsoon time. Sometimes when the things are settled, you are getting finer materials and they are getting deposited like this. So, in past, during the formations of Shivalik rocks, these sequences have developed and they play very important role in case of groundwater occurrence as well as yield. One more figure from the same area which you can see here, and that these layers are seen here. So, this is the completely fresh exposure. Many times it is very challenging to get such fresh exposures of rocks of Shivaliks, but anyway I was lucky to get this one. So, with this I thank you very much.